Hi, everybody. Thanks for joining today's webinar. It is What is Lakehouse and Why It Matters. I am Chandra Reddy, AWS Storage and Data Lake Specialist. I also have Srikanth Sopirala with me, who is an AWS Principal, Analytics Specialist, Solution Architect. I want to make sure we answer all your questions. So again, at the risk of repeating myself, please make sure you type your questions in the chat window as the webinar progresses. Okay. All right, so the agenda for today is it's packed with lots of real-life examples. Srikanth and I will be discussing a lot about some specific customer examples. I will start with some challenges with legacy tools and highlight them with a fast food example, and then I'll talk about Lakehouse, go through the examples, and then we'll touch a few topics on security. And also request everybody to go on mute. That would be great. You can definitely ask your questions in the chat window. All right, so data is growing exponentially as it's coming from a wide variety of diverse sources. The data producers are many, right? Think about point of sale transactions stored in relational databases or your ERP systems or CRM and other lines of business applications. The larger the organization, the larger the lines of business apps and the more data. Now, beyond these silos, you also have terabytes or petabytes of data coming from IoT devices, clickstream data from web applications, log data, and social media data. So, and then there are many consumers of data as well, right? So many different teams want to access the data increasingly in real time. And there could be many different applications that need to access and analyze the data. Bottom line is this: enterprises want to monetize their data, and grow top line, reduce costs, and risk for their businesses. The challenges they face is that they're struggling to manage all this data because of data silos. And what I mean by this is it's hard to access data securely and analyze it from all these various silos. Legacy tools are not a good fit to process hundreds of terabytes or petabytes of data, and that's the kind of data that we see being generated nowadays. So many organizations, what do? They discard data as they are limited by their storage and compute constraints. And some get stuck with legacy tools which can't innovate at a rapid pace. So that chokes your innovation speed. So more than often, many different purpose-built tools are required to process this data and deliver your business goals. So let me highlight this with an example. So think about, I just picked a fast food restaurant because I think we all can connect to this very easily. If you look at, let's assume that they want to extract some data insights. They want to find out what are the top items sold on a per restaurant basis. What items are customers buying along with a chicken sandwich? Why would they want such data insights? Because business outcomes they are trying to accomplish is they want to optimize costs or upsell and increase revenue. So how would you accomplish this? So when a customer buys a sandwich, right? What you want to do is that transaction needs to be stored, and typically it's stored in a relational database. That's a good fit to store transactions. And then, but that's not a relational database is not a good fit to do analysis for lots and lots of data. So what do? You extract the data and put it in a data warehouse, and then you do the data insights. So this is just one example for a very small use case. But then there could be more. Let's say you want to find out where did the user spend time while they were ordering the food in their application, in their mobile application. What items were removed by the user after adding them to cart. The number of users who were even unable to add a credit card into the app. Why do you want to analyze this? Because you want to improve the customer experience, and obviously you want to increase revenue. So how do you do this? Essentially, you can improve the mobile app experience by storing the clickstream data as users are clicking on your website or the mobile app. You can capture all those events and store in a data lake, typically an object storage. And then what you could do is you can join the data from the semi-structured data from object storage and the data that you have in data warehouse and come up with these analytics so that you can deliver the business outcomes, right? So that's a second use case within the same organization. Now, you might want some more data insights, such as you want to bring up past purchases as a customer is walking in or driving into a restaurant. You want to bring up past purchases and try to upsell, maybe add mushrooms to the burger or Colby Jack cheese from as they bought it from the last time. Why do you want to do this? Because you are optimized selling time and then, of course, increase revenue. So how do you do this? Imagine that as a customer is driving into the drive-through, maybe you want to stream the video data and pick up the nameplate, the car nameplate, and then use the data actually in almost real time to extract past purchases from your point of sale transaction tool or the data warehouse, and marry that information with the car nameplate that you just extracted out of the video. What does that do? So the teller now knows, oh, okay, yeah, the person, whoever is driving that car, last time they bought these menu items, and maybe they forgot to add mushroom or Colby Jack cheese, and hence you can do an upsell. So this is another example of real-time processing. Another example could be, if there are any challenges in the restaurants, you want to issue warnings and notify the contractor so that they can go fix the problem very quickly. So any kitchen sensors or anything coming out of the restaurants, you can store the IoT data, do the real-time analytics, and then store it in the data lake for historical trends. But then, of course, spin up some serverless compute, transform the data, and then notify the contractor so that they can go fix the problem. So as you can see here, the types of data is many. They're coming from many different sources. They need specific engines to analyze the data. And this is the challenge with legacy tools, where you just can't fit all this data into one monolithic architecture. You need the flexibility. So that's what you can achieve with a data lake, where you store the data, and then all these purpose-built managed services for you, so that you don't have to manage the infrastructure. Somebody else is doing it for you. And that is a lakehouse architecture. Essentially, you bring compute and analytics engines to the data that could be stored in a data lake, right? As highlighted in the previous example, you might need many different stores, analytics engines, and machine learning tools for various use cases. Data can move from, give me one sec. No, data can move from obviously all of these engines into the data lake, or out from the data lake to any of these engines and around the perimeter as well. So what are the critical capabilities of a lakehouse? So here are some that I can think of. The first thing is you really need an infinite amount of storage. You do not want to discard any data. You want to store all the data that is being generated from your data producers and store it. Legacy tools will not be able to cope up with that kind of volume of data. So you want a data lake with infinite storage. Amazon S3 is a good example in AWS. Of course, security is extremely important, because there are many data producers who are storing the data in data lake, right? So you want IAM, encryption, fine-grained access control, and for that, we have AWS Lake Formation, which can help you. The next thing is you have data from all these producers, and when you're querying, you want a central global catalog so that people can search across these various data stores. And for that, we have AWS Glue and Data Brew, which delivers it as a global catalog, and as well as it can do a serverless extract, transform, load. And then you want to do serverless queries, ad hoc queries. Amazon Athena is an excellent tool in AWS, which can help you do that. You want to scale compute and storage independently in a data warehouse, so that you can reduce your costs, and at the same time, you don't want to sacrifice your performance. That's exactly what Amazon Redshift delivers for you. And then if you want federated queries across not only your data warehouse tool, but also the data lake and other relational databases, you can do that with Amazon Redshift Spectrum. So this gives you complete flexibility and further reduces your cost, because you don't want to load all the data from your relational databases and data lake into your Redshift cluster, which might become huge. Instead, you want to do some federated queries, and we can help you to do that. And last but not the least, we also talked about, in the previous example, how we extracted the car license plate from a video, looked it up from the past purchases, and suggested anything else that the user might want to add into their burger, right? So there are many other things that you can do with machine learning. These are all out-of-the-box tools available. You can extract text, insights, forecast demand, prevent fraud, computer vision, analyze image. Depending on your vertical industry and your use cases, there are many ready-to-made AI services that you can leverage. And then, you want fully managed data stores and engines. You don't want to be in the business of managing the infrastructure. Let somebody else do that for you. And that's exactly what this lakehouse tools deliver for you. You want high durability and availability, so you have the peace of mind that your data is never going to be destroyed. And of course, you want to grow and shrink on demand, storage, compute, everything. You want to have the flexibility to grow and shrink on demand. So these are some of the critical capabilities that I could think about for a lakehouse architecture. And Amazon delivers fully managed services for all these various components that I just explained. The benefits for you is it will help you increase your top line growth from a business outcome, optimize your operational costs, and reduce risk. So with that, I would like to go through some use cases and some real life examples. Shrikant, can you hear me? Can you come out of the mute?
Yep, I'm here.
Awesome. So Shrikant, tell me about this example that we talked about, the real estate company. What were the customer challenges?
Yeah, so this is a classic use case where most of the real estate companies, right, what they're trying to do is they're trying to build the smart buildings use cases, right? They have these data sources that are coming from, various cameras and CCTVs and IP capable devices and sensors. And what they want to do is, of course, the main component of this is the IoT infrastructure. But beyond that, they want to kind of do analytics on this data, right? And that is where they choose this lakehouse approach, right? That's what that is the use case. Why do they want to do that? I mean, obviously, for example, like you have HVAC, you have lighting, you have all of these sources. They want to know more about that, who is using what, and metrics and data. End of the day, they just want to make sure that they can collect all this data, but then how do you analyze that, and then how do you gather analytics on top of it?
Right. And the desired outcomes were, obviously they want to improve the occupant retention and all. For those desired outcomes that, you see on the right-hand side of the screen, how did they solve the problem? I mean, how did they get all the data from these data sources? Can you talk a little bit more about the architecture?
Sure. So the way what they have done is they've gathered this data from various apartments, various buildings, right? Using the IoT infrastructure, site-wise and other green grass and other IoT infrastructure. Once they have that data, what they have done is they've landed the data using Kinesis data streams, which is basically our real-time streaming service. And then from there, they have two paths. One is they can run what is called Apache Flink or Kinesis data analytics, where they can do real-time notifications. For example, if there is a device that's broken and then they want to notify the tenant as soon as possible, they would use that method, right? It's more of a real-time notification service as the events are occurring. And then the other approach that they've used is more on the batch side of it, right? So I have collected all this data. Now I want to do some aggregation, some analytics, some insights into what is going on with my building or what is going on with my HVAC units. What they have done is they've used data warehouses, right, or EMR for batch processing. First of all, I can do some ETL processing, crunch all the numbers, and then feed the data back into S3 so they can save that data into a data warehouse like Redshift, right? The end of the day, when they process with the EMR, they can also use SageMaker for predictive modeling, right? For example, most buildings or any buildings, there is a predictive maintenance component of it, right? So they could use predictive maintenance algorithms using SageMaker from the data that they've processed, and then they can publish those events or notify the tenants.
Thank you, Shrikant, for the details. So it kind of proves what we were talking about, which is you need different tools, different processing, different analytics engines, and machine learning capabilities. And you bring those tools to the data that you're storing in these various data stores. Shrikant, so what was the business impact of using such a lakehouse architecture for them?
Yeah, that's a great question. So, end of the day, I mean, these companies are doing that because there are two reasons, right? One is they want to be more efficient. They want to build a loyalty, a base, right, with their tenants, and they also want to basically cut costs, right? So, when you have a single source of truth and not all these silos of data, right, the ability to move the data between the data lake to a data warehouse or to another machine learning So you provide customers with these insights, and then this is where the lakehouse really shines, right? Because and also it is all managed infrastructure. So cost is one of the key factors, and also loyalty and having more customers, right? Having satisfied customers is another key thing that these guys are looking at.
Perfect. And of course, predicting the failures. Thank you, Shrikant. So let's move to the next use case. This is about an aviation company. Tell us about this use case and what were the customer challenges?
So this is an aviation company, which is basically a private aviation company, right? They have their own airplanes, but what they get all this data from various data sources. For example, the Federal Aviation Administration has data called swim data that comes in, which is a lot of components of it, and then they have the on-time performance data, which is basically a statistical data for the last 30 years in terms of on-time performance over all the flights. What they were trying to do is they were trying to predict the airline delays for their crew members, because their crew members have to fly to their own private airplanes in different airports. So they were trying to predict the delays of the general airlines like American Airlines and Southwest and other things. And then they were using this data, but they didn't have any method to do this because they were doing all manually in Oracle databases or manual processing in Excel spreadsheets. They were trying to find a way to do this.
Got it. So how did they solve this problem? Looks like there are many different data sources, and they wanted to quickly predict, aircraft delays for their pilots.
Yeah, so once they realized that they were going to do this on AWS, they started collecting all this data, right? They also had reservation systems where they have their own reservation systems which are running an on-prem system. So they took all this data, right? They streamed the data into Kinesis data streams, right? For FAA, they have this mechanism where you can tap into their FAA streaming data. They stream the data into Kinesis, and then from Kinesis, what they did is they did analytics on using Kinesis data analytics and Flink. They were able to use that. So as the airline data is coming in, they can see if they can enrich the data using the KDA, Kinesis data analytics, from their own systems and see if there is any immediate delay for that particular crew member on that aircraft. And then they would send a notification. Basically, the end of the day, what they're trying to do is have their own reputation intact, right? Because they have to send the crew members to their airplane so that they can serve their customers. So that's one thing. And then they were also collecting all this data, right? They wanted to kind of track all this aircraft, their own aircraft, because this data is also streamed through that same stream. So they would store all that data into a DynamoDB type database where they could have a dashboard built basically with QuickSight or with Grafana or with some APIs where they can put a dashboard of their own aircraft, which this is all from the same stream of data. And then how do you perform batch analytics, right? They also took all the data. They streamed the CDC, the change data capture data using database migration service from their own Oracle instances on-prem. They pulled out all the data into the data lake, and then they moved the data into a data warehouse where they would create the business intelligence reports or dashboards for their executives and then for their other leaders.
Got it. Thank you. So essentially, they're doing both real-time analytics and batch analytics, again, by using these various lakehouse components, if you will, and essentially bringing the compute and the analytics engine to the data wherever it's stored. So what was the business impact of using this lakehouse architecture?
Yeah, I mean, the business impact were, because the thing that they were not able to, and also this is a massive amount of data, right? They were sending, FAA, for example, sends 5,000 records a minute, right? So the scaling their on-prem databases or their Exadata machines or their data warehouses was not good enough, because they would be spending tons and tons of money just increasing that the infrastructure. So that is a huge thing. So they save humongous amount of dollars dollars in terms of cost when they move to the cloud, number one. And then also because cloud provides you that scale in terms of the storage and then the flexibility in terms of the particular analytics. So previously they were just doing all the analytics in one database. That's all they had, right? They didn't know anything else. But now with Dynamo, with Redshift, with Kinesis, data analytics, they had this multitude of the analytics tool sets in their tool belt where they could use this. And so with this, they were able to achieve that outcome in terms of predicting delays and also basically customer satisfaction end of the day.
Got it. Thank you, Srikanth. That was great. So let's move on to the last example, Epic Games. I think we all know about the Fortnite. Can you talk a little bit more about all these various data sources and what were they trying to accomplish?
Sure. I mean, Fortnite is a very popular game. If you think about it, Epic Games, they have about 140 million players, and they're growing constantly, right? It is basically it's a revenue. Fortnite, what it does is it collects all these microtransactions, and then Epic basically depends on this, and they continuously capturing the attention of the gamers through the new content that they're posting, right? The idea is they wanted to kind of have this real-time data input into there so they can improve the player performance and also the satisfaction, right? They wanted to get up-to-the-minute insights for the gamer experience. That's the use case for that.
Got it. So you're saying that as 140 million users are playing the games, in the real time, they want to get insights into the gamer experience, and in the real time, they want to change content?
That's right. Yeah. So they want to kind of take the in real time, gather all the data, and then give them the experience, and then change the content on the fly that based on what the gamers or what the players are basically playing. And that's what they wanted to do. And the amount of data they were collecting is in petabytes, right? So they wanted some kind of mechanism to do all this work.
All right, Srikanth. So explain to us how did they do it?
So what they did is they basically in this type of scenario, right? The sources were like they had game clients, right? They have game servers around the world. They have game different services, basically telemetry data. They were collecting all of the data as it's occurring, and they wanted to have a real-time streaming service, which is basically the Kinesis data streams. They used that. They collected all of that data, right? And then what they did is for the real-time experience, they used the EMR on Spark, and then they were able to gather all of that information, process it as soon as they're receiving it, and put into DynamoDB with fronting with a Grafana or the API dashboards to create that real-time experience. So as they're collecting the data, they would process it, and they would kind of cater to that using DynamoDB, which is our NoSQL database, and then they would put on top of it, they would have Grafana dashboards and then the API. And then the other thing they were also doing is basically the batch pipeline, right? In here, what they were doing is they were processing all of that data, putting into the data lake, which they built, and then for the bulk batch processing requirements, they were using EMR, which is more of a permanent cluster EMR, where they would have running that EMR, and then from there they would process all of the data, put it back in the data lake, and then their ad hoc, they would run ad hoc analytics using the Presto engine or the Athena engine. That way they can gather more insights from that data.
Got it. Now, this is very impressive. Doing this in real time for 140 million users is awesome. Thank you. Thanks, Srikanth, for giving us the insights on how they were able to do this with the Lakehouse architecture. Again, going back to our Lakehouse architecture, bring all the analytics engines, data store capabilities, ML capabilities to the data that you are storing.
That's right. I mean, the story here is very simple, right? It is a purpose-built story. We are not using one analytics engine to do all your work, right? We have DynamoDB. It has its own purpose. We have EMR. It has its own purpose in this pipeline. And we have Athena. It has its own purpose, right? That is the story that we have with the Lakehouse.
Yep. Got it. And even within EMR, you can see that it can be used for real-time as well as batch processing. So it's really flexible with respect to your use cases. All right, so let's switch gears. Obviously, when you're handling so much amount of data, security and compliance is extremely important. I did want to share about this excellent blog And we'll make this presentation as part of this. But please do read this blog. It's an excellent blog written in collaboration with JP Morgan Chase on how they built a data mesh architecture. The idea here is to actually, instead of having one single team who is in charge of getting the data and cataloging the data, the idea here is that there are many different producers, right? As you can see here, each business process has their operational system, red, yellow, and blue. Each producer creates their own and controls their own data lakes. And they actually determine who needs to get access to the data. And those controls are stored in a mesh catalog. Okay. So the red lake determines who can access what data, even at a row and a column level in the mesh catalog. And then the consuming applications, there are many different consumers, and then the consuming application would essentially request for whatever data is needed, and then the producers would effectively allow or deny access to their requests, right? And all those controls are stored in the mesh catalog. So the beauty of this paradigm is that it empowers the data producers to control data sharing rather than not having the peace of mind for producers on who has access, right? Because some other team is deciding on their behalf. So that goes away, empowers data producers to control data sharing. Second is, once the data is stored here, you don't have to create a copy for each consuming application, right? Instead, this is a shared approach where using the mesh catalog, control access, the consuming application can directly access the data here, access fine-grained data in the red lake as an example, right? And last but not the least, it provides cross-enterprise visibility of who is consuming what data because of the centralized nature of mesh catalog. Srikanth, is there anything else you want to add to this?
Yeah, I mean, I think if you think about it, data mesh, right? I know most of us are already probably in doing that, right? In the past, what we have done is we had a centralized team managing all our data lakes and all our data ingest and all of that. But these centralized teams didn't know much about their data, right? The data domains. They didn't understand what the data looks. So basically, it took a long time for them to understand the data, process the data. So this data mesh provides the alternative approach, meaning data as a product where your producers basically own the end-to-end pipeline, right? When they have that, the key part becomes the federated data governance, because now that the producers own end-to-end, there is no centralized data lake teams. The producers basically have to have a proper governance. So all of these producers, in your case, it's red, yellow, or blue, have to basically publish that data into a centralized data governance catalog where you could have a common access pattern, right? Because the consumers can come in and they would want to access through the catalog, and that is what the data mesh is. I mean, I'm sure most companies are already doing it because that provides you a little bit of freedom in terms of accelerating your data lake and your data lake architectures.
Thank you, Srikanth. Can you talk a little bit about how would somebody do that in AWS? What tools do we offer to create those right access controls in data lake?
Yeah, so the central data governance, again, is the key in a data mesh, right? Basically, what it does is it stores a data catalog of all your enterprise data, all your access accounts, and it provides the producers to register and create a catalog entries. So for that, in AWS, Glue catalog is a place where you would use that. So that the catalog would be a Glue catalog. And then when you talk about you basically, what you're doing is, as the producers are creating these data sets, they would create and they would register in the Glue catalog, making it published to the consumers. And that's where Glue really fits in terms of the data catalog. And then when you come to access, right, in a data governance, there are two things. One is the cataloging your data, understanding where your data exists, and the other one is who has access to my data. How do you control that? And that is where lake formation comes into picture, right? Lake formation provides you that uniform access control of this enterprise-wide data sharing mechanism, right? And that is where it is for auditing and for your centralized governance, for your access control, and lake formation plays a pivotal role in that architecture.
Got it. Thank you, Shrikant. So we introduced two concepts today. One was the lakehouse, and the second is the data mesh. I do want to explicitly mention that this is not either or, right? So this is and. So you still need all those lakehouse components to pick the right analytics engine or data processing engine on your data. But at the same time, what data mesh architecture allows you to do is do it in a fashion that we just described, wherein it empowers the data producers to control the data sharing. So
That's
they
right.
both are absolutely, you can leverage them.
That's right, Chandra. So think about this, right? Data mesh is a bigger picture architecture, right? But then you need when you're implementing the data mesh in AWS, you would use the central data governance, data catalog, glue, and lake formation or access control. But then the lake house becomes a blueprint of how you build these producers and consumers, right? Because that is what you would use that infrastructure, that architecture for. So lake house becomes an integral part of your data mesh, where when you're building that, so you can create a blueprint. For example, tomorrow you add another violet producer, right? Violet color in your chart, right? There is a new producer. You don't have to reinvent the wheel. You basically use the lakehouse architecture to build that producer components, and that way you can accelerate your build.
Got it. Thank you. And the last one, we want to talk about a little bit about serverless and federated queries. So Shrikant, if somebody, there are like many different data comes from many different sources, right? And it might not be in the right format. So there's a lot of data cleansing that needs to happen and data transformation that needs to happen. And for very large volumes of data, like hundreds of terabytes or even petabytes, what is the best tool to use for data cleansing and transformation?
Yeah, so I mean, again, depends on the use case, like you said. So in AWS we have a couple of tools, right? One is we could use AWS Glue, which if you're writing your code in Spark and you want serverless, you don't want to manage any infrastructure. Glue is a great ETL tool to do that big data processing, right? You get charged by the second by paying for DPUs. So it's a people who are starting on their big data journeys who don't want to manage a lot of infrastructure, I think they tend to choose Glue. Right. Then we have EMR. EMR is if you want to use Spark or beyond Spark, any other frameworks, or you're already migrating from an Hadoop ecosystem on your on-prem, EMR is a great choice, right? You want a like-for-like migration, and then because you want a little more customizations, then EMR is a great tool in terms of big data processing. And then we have Data Brew, right? We have recently released a tool with Data Brew, specifically catered towards the data analyst and business analyst, right? Where you don't have to write any code when you're processing this data, right? You have all this data sitting in your data lake or in your data warehouse. And then we provide about 250 transformations, and you don't have to write a single piece of code. It basically, Data Brew provides you that mechanism to kind of process that data and then format the data and then get back to the data lake. So that is another tool of choice that people are using.
Got it. Thank you. What if I have a scenario where I have data that is stored, semi-structured data stored in S3, and I have some relational data stored in, let's say, an RDS instance. It could even be on-premises in an Oracle or a SQL database. And then I have some columnar data stored in a data warehouse. So, one approach is obviously to take all this data and load it into a data warehouse. But then the other approach is load only what's really, really needed into the data warehouse, and rest of it keep where it is and do a federated query. Is that possible, and how do you do that?
That's right. So, and that is the heart of the lakehouse architecture, right? If you think about it, we have been most customers have traditionally been running on-prem, and they have sometimes, I work with customers where they have 10 or 15 years of data sitting in these data warehouses. They don't archive the data; it sits in there and then the cluster keeps growing bigger and bigger. So when you move that architecture to AWS, what you could do is because not every customer is going to be using all those 15, 20 years of data. So you can keep your 5 years of data or 3 years of data, whatever your limits are, put that in your data warehouse, like a Redshift data warehouse. And then you can leave the other 12 years or 15 years of data in your data lake, right? And then the way you access that, because you don't regularly access the data, right? You only do that when you're building a forecasting model or when you're doing some historical analysis. is for that, what you could do is Redshift provides you a mechanism called Redshift Spectrum, where it provides you create an external table in Redshift, and then you can basically you get additional compute to process that data and then join the data with your data warehouse. So that's a classic lakehouse architecture. But also we have another feature called federated query in Redshift, right? Let's say, because most of the time, the ETL that you don't write is the best ETL, right? What we have done is we have created a mechanism to join the data from a Postgres or a MySQL database from Redshift directly without writing any ETL. You can directly, with the federated query feature, you can join the data from Redshift to a MySQL or a Postgres database, and then you can run it without writing ETL. So end of the day, what you're doing is, if you have online transaction processing systems in MySQL or Postgres, if you have a data lake and you have a data warehouse, you can join all of this data and then process the data in the Redshift data warehouse itself.
Great. I do want to double click on another related use case, Srikanth. So, semi-structured data or unstructured data, most customers just understand instinctively that, let's put it in an S3 data lake. But the relational databases, the jewel crowns, right, of ERP systems, not every customer is ready to migrate that database into AWS. They, for many different reasons, they might want to hold on to that jewel crown database application in their data centers, right? So is it possible to leave the database wherever it is and extract the data out of it, put it into the data lake, and do whatever analytics is needed? So you still get the desired outcome, but you don't have to necessarily migrate those on-premises databases. Is that possible?
That's right. Yeah, it is possible. So there are two ways to do that, right? One is most customers are trying to do is they still need to run their business. So they have these on-prem databases. They still need to run that. But then also they are slowly moving their reporting capabilities to the AWS because of the cost effectiveness of running data lakes in AWS, right? So they migrate the data, or they move the data or replicate the data to the data lake. And then in here, what you can do is, you can, if you don't have a data warehouse in the AWS ecosystem, you could use Athena, which is an ad hoc analytics tool to basically, you can catalog the data that you have moved into AWS, and then you could use Athena to query the data and run your ad hoc analytics queries. That's one approach. And then I have seen customers, for example, they have Teradata, right? They're in the process of migrating their Teradata into a data warehouse, but then also they want to join the data from on-prem Teradata with their Redshift or with their data lake, right? What they do is they use Athena in Athena, there is a feature called federated query, right? You could use and there are third-party products like Trians where you can use Athena federated query to join the data in a Teradata system and then bring the data back, and then you can run the queries. So that's another mechanism. So Athena becomes a really important tool in your tool belt when it comes to ad hoc analytics, joining the data in the data lake and also your on-prem systems.
Got it. And since you talked about Athena, right, it's a great tool for serverless queries. But then we also have Redshift Spectrum, which does similar. When should I use Athena versus Redshift Spectrum?
No, that's a great question. I think customers ask us all the time, right? So the Athena is more built, so it's built on a Presto engine behind the scenes, right? So Athena is more for ad hoc analytics, right? You have your data scientists, your data analysts or data engineers. They're trying to quickly discover the data, understand what the data characteristics are, run some SQL queries, answer SQL queries, and then try to understand data. Ad hoc analytics, Athena is a great tool. But then you might say, if you have a data warehouse already running, right, and then you have data lake, which then I think the best approach is basically using the power of data warehouse. And if you want to use more aggregations, more MPP architecture, then you use Redshift and then use Spectrum to join that data. Again, two different use cases, because you can start with ad hoc analytics with Athena, catalog the data. But then if you have a data warehouse, then I would use Spectrum because I get more compute. And also I am also using my existing data warehouse capabilities.
Got it. Thank you. Thanks, Srikanth. I think that clarifies all of it. So just to summarize, bring home to all of the discussion, the benefits of data monetization using Lakehouse architecture is essentially it falls into these three buckets. You can increase your top line growth, you can optimize your operational costs, and of course, you can reduce the risk. So that's what we had to share today. I want to thank you for your attention.